Hi everyone, in this video we'll be learning about the chapter on fuels and crude oil. Now this is actually our start on the chapter of organic chemistry, or rather the whole series of chapters on organic chemistry. So in this chapter we are actually going to start first by understanding a bit more about how crude oil and fuels are actually sources of various organic compounds, and then we will actually move on deeper into the various kind of organic compounds in the next few videos. So without further ado, let's get started with this chapter. Now in this chapter, right, we'll be exploring exactly the importance of understanding about fuels and crude oil, how are they being separated, what are they being separated into, and last but not least, we're also trying to understand a bit more about sustainability, right? Because we know that fossil fuels is a non-renewable resources. So what are cleaner ways, what are better ways to continue to allow us to enjoy the use of fuels and energy, but not in a way that we'll be using up all these kind of fossil fuels. So in this video itself, there's a few lesson objectives. Number one is for you to understand about these fossil fuels called natural gas as well as crude oil. Next is to be able to describe crude oil as a mixture of hydrocarbons and understand how fractional distillation is actually used to actually allow us to get fractions of different components that can be used as fuels or as a form of source of chemicals. Next, you'll be learning about this chemical called biofuels and understanding about how biofuels is actually more useful, or rather more environmentally sustainable for us in terms of carbon dioxide emission. In the previous part of this chapter, in the previous syllabus, right, actually your seniors will have learned about the various fractions of the crude oil when it's being separated. But I'm happy to let you know that in your syllabus, in your national exam, you are actually not required to know all these different fractions as well as their uses. So let's first get started in terms of what exactly is crude oil and natural gases, right? So crude oil and natural gases are essentially different types of what we call fossil fuels, right? Besides crude oil and natural gases, there's also coal, right, which is basically charcoal, right? So these are all used to supply us with energy. So in case you're not too sure how are crude oil and natural gas form, now this is usually formed as a form of fossil fuels, right? And we all know that fossil fuels are formed from millions of years ago, whereby there are various organisms that actually died, and when they sink to the seabed, the various heat and pressure that acts on these organisms' dead body, right, over millions of years, eventually results in the production of crude oil and natural gases. So how do we actually get hold of crude oil and natural gas? We actually drill deep down into the seabed and actually pump out all these useful fossil fuels, right? So if you have watched videos or documentaries before, you have seen before these things called oil rigs in the middle of the water, in the middle of the oceans, right? Those are actually huge structures that are being designed to allow us to pump out the fossil fuel from the way below, deep in the seabed. Right, so this is just another example of what it looks like when they actually drill down into the seabed to extract out the crude oil as well as natural gas. So let's talk a bit about crude oil first. Crude oil is also known as petroleum, right? So this is actually a dark brown and rather smelly liquid. Okay, it is actually a mixture of different hydrocarbons. Now, what exactly are hydrocarbons? We'll be learning this in the next chapter where we talk about alkanes and alkenes. But for now, just take note that hydrocarbons refers to compounds that contains only carbon and hydrogen. Right, so I just write the chemical symbol over here. So the formula of these chemicals is just a certain number of C and a certain number of H. Okay? In order for crude oil to be useful for us, we actually have to separate them out. If not, crude oil as it is, right, has no meaningful use to us because it's a mixture of various different hydrocarbons. And then when we refine oil, that's where we can actually separate crude oil into useful fractions. Right, so we're going to watch a video now to understand a bit about the fractional distillation process. This is a rather old video, but it still holds relevance because the method still remains the same as per today.
Crude oil is a thick, dark brown liquid found deep in the Earth's crust. It's a mixture of different hydrocarbons, molecules made of hydrogen and carbon. Some molecules in the mixture are very small, just a few atoms joined together. Others are far more complex, with many atoms forming long-chain molecules. But as a mixture, it's useless. The different hydrocarbons need separating. The technique used is distillation. This simple apparatus is set up in a fume cupboard. Mineral wool stops the mixture spitting when it's heated. Crude oil is dropped into the bottom of the tube. A collecting bottle is put in place. And a thermometer level with the sidearm monitors temperature. The final step is to gently heat the mixture by immersing the tube in a hot water bath. The hydrocarbons with lower boiling points begin to vaporise immediately. They're flammable, so it's safer not to heat with a naked flame. As the vapour rises, it enters the sidearm, where it cools and condenses. This happens at about 40 Celsius. The hydrocarbons which boil at this temperature drip down the sidearm and form our first fraction. It's a colourless liquid. The temperature stays at around 40 until all the hydrocarbons with this boiling point have vaporised. The hydrocarbons left behind aren't hot enough to vaporise. Their boiling points must be higher. Once the first fraction has been collected, it's safe to start heating with a Bunsen. As the temperature rises, other hydrocarbons begin to boil. A new fraction is collected at about 60 Celsius. It's slightly yellow in colour. And so the process continues. By carefully heating the oil and collecting the liquids which condense at a number of different temperatures, the many different hydrocarbons in crude oil can be separated. This is known as fractional distillation. On a larger scale, a fractionating column is used. The oil is heated with an electric heater for safety. The vapour is condensed by a Liebig condenser and is collected in a conical flask. Hot vapour rises up the fractionating column. It's a long way to go, and the further from the heat source, the cooler it gets. Most of the vapour condenses on the glass spiral inside the column and drips back into the mixture. Only the hydrocarbons, which are still vapours at the very top of the column, enter the sidearm and condense to liquid. Industry uses the same process, but on a mammoth scale, in huge fractional distillation columns. The hot oil enters near the bottom, at a temperature of 330 degrees Celsius. The column becomes cooler towards the top. Fractions which remain as vapour at 85 degrees Celsius go straight to the top and are piped away. Different hydrocarbons condense at different temperatures, running off at various levels. Those with lower boiling points are collected at the top. Those with higher boiling points run off nearer the bottom. The longer the molecules, the higher the boiling point. Industrial distillation separates crude oil into useful fractions, each containing molecules of a similar size.
Right, so as you can see in the video, there is this whole process of trying to separate the crude oil into different components, and we actually do this using a method that we learned before in Sec 3, fractional distillation. We all know that fractional distillation is basically a method that allows us to separate chemicals based on their boiling point, right? So in the whole fractional distillation process, in this case, the chemical that has a lower boiling point will usually be the chemical that's made out of smaller molecules. The one with the higher boiling point is the chemical that's made out of larger molecules, right? And the one that has a lower boiling point will actually be separated at the top, right? So the top part is actually where you have a lower BP, which is boiling point. Oops. And the one at the bottom will be your highest BP, highest boiling point. Okay, so it's the same thing as we've learned in secondary 3. whereby the lowest boiling point chemicals get separated first, right? For instance, the fractional distillation that we have in school. Okay. So as I've mentioned, the lighter fractions will be separated at the top of the fractionating column, followed by those who are somewhere in between. So the lighter fraction will also refer to those with lower boiling point. Right, so you realize that over here in this chapter, we're trying to introduce you to this idea that the molecular mass of the chemical can also affect their boiling point. And the heavier fraction will be those that has the higher boiling point. They will be collected at the bottom of the column itself. So as I've mentioned, lighter fractions are usually made out of smaller molecules and they have lower boiling point. Heavier fractions are actually made out of larger molecules and they have higher boiling point. So essentially that is what you need to know in your syllabus. So what exactly happens? Basically, we will actually, at the bottom of the fractionating column, the crude oil is actually heated up to form a vapor, right? Then the vapor will actually enter this separation column over here, whereby, so you enter this huge fractionating column that separates it based on boiling point, right? So those with the higher boiling point will be separated to the bottom. Those with the lower boiling point will be at the top. Right, so as I've mentioned earlier, if you look at it over here, you see various chemicals, right? You see different names from petroleum gas to this thing called naphtha, kerosene, diesel oil, lubricating oil, bitumen, etc. This is not required in your syllabus anymore. In your seniors batches, they do have to remember the sequence and the order of what comes out at the top, what comes out at the bottom, and they also have to remember what is the use of the various components inside the crude oil. Okay, but for your batch, you actually no longer required to do that. Okay, so as I've mentioned, do take note that in this whole fractionating column, separation is not sequential, which means to say that the separation will actually happen concurrently at the same time, right? It's not that, okay, petroleum gas must come out first, then once all the petroleum gas is over, then petrol can come out, then naphtha can come out, then kerosene. Okay, that's not the case. Over here is concurrently the various components will actually be separated out, not sequential. That's what this page is trying to tell us. Right, so take note, it's a concurrent separation. And as I've mentioned just now, this is just good for your information, right? There's different components that's being separated out, and they're actually used for different purposes. Okay, but there's no need for you to no need for you to remember what are the different fractions and their uses. So, what exactly are the uses of crude oil? Now, this was actually one of the very older O-level questions that whereby students are actually required to share about what do they understand about how crude oil can be used. So I think first and foremost, we do understand that fossil fuels, about 90% of all the crude oil produced is used as fuel to generate electricity, drive motor vehicles, and provide power for industrial activities. Even though the world is moving towards green and clean energy, a lot of the various processes and factories, industrial activities still depends on fossil fuels. Secondly, it's also important to know that crude oil is also used as what I call a chemical feedstock. Now, a chemical feedstock refers to kind of like an ingredient or starting material that's then used to make other kind of chemicals. So, for instance, over here, just now you have seen this word called naphtha, right? Naphtha that's being separated out can actually be used to make useful chemicals like medicines or even plastics, right? So, we actually use crude oil to get the useful components, then to use it to make other stuff. So this is the reason why crude oil is still pretty important in our day-to-day use. But with this also comes certain challenges, right? So we know that petroleum is fossil fuel, and fossil fuels are non-renewable, right? Since you're non-renewable, it means that you're a finite resource, which means that it will be used up one day, or that it will be depleted one day, right? And if that's the case, then we will end up with no more fossil fuels. So we shouldn't allow this to happen. That's why it's important for us to know what are the various strategies that we can do. Okay. Secondly, we all know that burning of petroleum can cause pollution. Now, we have learned before in the air chapter that incomplete combustion can cause chemicals like carbon monoxide to come out, right? And likewise, if you have coal that contains or petroleum that contains sulfur, if you were to burn it, you actually generate this harmful chemical called sulfur dioxide. Right, so these are issues that can arise. And of course, not forgetting that whenever you have combustion, it also generates what we call CO2, right? CO2 is a greenhouse gas, and having too much CO2 can actually result in global warming, a rise in the global temperature itself. Right? So this is the reason why we need to look for other methods to help us to solve this issue. Right? And we also need to cut down on the use of petroleum. So let's first talk about cutting down first, which is conservation. Conservation of petroleum can be done through a lot of manner, right? It be in terms of the way you take certain transport, to take public transport instead of owning a vehicle, right? We can also save petroleum by using alternative energy sources, so using things like solar energy, nuclear energy. In fact, if you follow the news this year in 2025, the government is actually exploring how can we harness nuclear energy to actually support a lot of the electricity demand in Singapore itself. And of course, in terms of solar energy, a lot of the buildings in Singapore have already installed solar panels, right? In fact, a lot of the HDBs will have the solar panels at the top of the blocks in order to capture the sunlight and then use of it for to generate electricity. So there is ways that we can do certain form of conservation to cut down the use of petroleum. Okay, so just to highlight again, right, we mentioned just now a lot about fuels, about the kind of effects that can arise. Do take note that we understand that during complete combustion, that's where the fuels can react with oxygen to generate carbon dioxide and water. But do remember that there's also this thing called incomplete combustion, right? And incomplete combustion is when there is limited oxygen, right? And once there's limited oxygen, it actually forms carbon monoxide, soot, and these are actually your pollutants. So just to quickly show you as a table over here, right, natural gases mainly consist of methane, CH4. You'll learn more about this in the next chapter, right? And petroleum is a mixture of hydrocarbons, like what was mentioned just now, and coal is essentially mainly carbon, right? And these are just some details about the various fuels. So that is about how we can cut down the use of crude oil, right? But what are the alternatives that we can explore? So a lot of investment and technology has been pumped into finding various alternative forms of energy. And one that's of particular interest to us is actually this one called biofuel. Now, biofuel is actually a chemical that is being derived from sugarcane. You know the sugarcane that you drink when you go to the market, right? So using sugarcane, we can actually form this thing called bioethanol. And this bioethanol, which is a type of biofuel, is an alternative form of energy compared to natural gas and crude oil. So this can then be mixed with petrol, and then it can be used to run vehicle engines. There's also other type of biofuels, right? So biofuels could include things like biodiesel as well as biogas, right? So this is just some examples. But in the syllabus itself, we are focusing a lot more on the biofuel that comes from sugarcane. Right? So how does this make it a better, a more environmentally sustainable energy in terms of carbon dioxide emission? Right, so in your notes itself, do copy down the next few parts in this slide, because these are very crucial in terms of the explanation of why exactly it is more environmentally sustainable. First, biofuel is more environmentally sustainable as the carbon neutrality is achieved. Now, what exactly is the meaning of carbon neutrality? Right, for the geography students, you may know this, right, but if you are not too sure about what is the meaning of carbon neutrality, look at the next 2 points. Number one, we know that combustion will release carbon dioxide. So it is bad, right? No choice, when you burn these fuels, there will be carbon dioxide. But because biofuels come from sugarcane, which come from plants, so those plants will have already taken up some carbon dioxide in their lifespan as they do photosynthesis. And then the photosynthesis is then used to generate the chemicals that's required to form the biofuels. So what you see over here is that there's this thing called carbon neutrality, whereby the CO2 released is offset by the CO2 taken in by the sugarcane plants. Right, so in this case, even though we know that there will still be harmful greenhouse gas carbon dioxide coming out, but because this entire energy source came from a plant, and the plant itself will have done photosynthesis, will have used up carbon dioxide, so it helps to balance up this carbon dioxide emission. So this is the reason why biofuel is actually a more environmentally sustainable fuel as compared to your crude oil or natural gases. Alright, and with that, we have come to the end of this first video on fuels and crude oil.